All right, so we're continuing with being able to solve a system of linear equations, but specifically we want to focus on those special cases. Now, we've kind of talked about these before. We talked about if I intersect with two lines, when we were talking about graphing a system of linear equations, that meant we had one solution. We said if we had parallel lines and they never crossed, we had no solution. And of course, if they were the same line, one line on top of the other, that meant they shared every single point and we had infinitely many solutions, okay? Now that was back when we were talking about graphing a system of linear equations. Now, the same rules here in a sense still apply when we're talking about it in terms of algebraically solving, such as by substitution and elimination. Okay, but what we look for is a little bit different. So visually speaking, we look for parallel lines or the same line. Now, when we're talking about it from an algebraic sense, when we're solving by substitution or elimination, a system has no solution if we result in the final statement in which it's a false statement, such as 0 equals 2, okay? So if you're solving by substitution or by elimination and you get a false statement, such as 0 equals 2, that's false, 0 doesn't equal 2, that would be a no solution situation, okay? So maybe let's look at one of these examples below there, and then we could do the other one in class. Let's solve one by substitution. Why not? We haven't done that in a couple of the videos. So a good reminder on solving by substitution on number 1. Okay, so remember when we solve by substitution, we need one of the variables for one of the equations solved for. Now, I noticed that x is by itself already in terms of not having a coefficient. All we really need to do is move the negative 8y over, and then we'd have x truly by itself, okay? So let's take x minus 8y equals a negative 4, and let's solve this for x, okay? So let's add 8y over. And that moves our 8y over so that we can truly have x by itself. We're isolating x. This goes away and we get x equals 8y, a positive 8y, minus 4. Okay, so now we know that x is equal to an 8y minus 4. So what we can do is take this, take our expression and substitute it into the x value of the second equation. Okay, so replacing this in for x here, we're going to have a negative 2 times the new expression that we found that x is equal to, 8y minus 4, okay, plus 16y equals 5, okay? Now, applying the distributive property, we have a negative 2 times 8 is a negative 16y. Then we have a negative 2 times 4, negative and a negative make it positive. 2 times 4 is 8, plus 16y equals 5. Well, notice we have a negative 16y and a positive 16y. If we combine like terms on the same side, those guys would cancel out. They're essentially 0, right? And we don't have to write 0. They essentially just cancel each other out, and we're left with 8 equals 5. Now, is that a true statement? Can 8 equal 5? No, that's a false statement, okay? So when we get a false statement, that would be no solution. Whoops. There we go. That would be no solution, okay? So for that example, number 1, we'd have no solution, okay? Now, let's go down to these examples here. When solving by substitution or elimination, a system has infinitely many solutions, and that will result when we have a true statement, okay? So it has to be a true statement, such as 4 equals 4. Well, 4 does equal 4. That is a true statement, okay? So when we're looking for a true statement, we're going to have infinitely many solutions. Since we did substitution last time, let's work on the one that does elimination. Let's look at number 2, okay? Now, just a reminder on elimination, we could check to see if we have opposite coefficients and we could add or subtract right away. If we have close to opposite coefficients, just they're both positive or both negative. In this case, we don't have either of those situations. Notice we have 8 and 18, 4 and, well, we should include the signs negative 8, negative 18, negative 4, and negative 9. So in this case, we don't have opposite coefficients, okay? Now, we could try and create opposite coefficients by multiplying by one constant for one of the equations. But even then, I don't see a case here where we could just multiply by one number. Instead, it looks like we're going to have to multiply by a constant to both equations. It could be the same, it could be different, so that we can create opposite coefficients. Now, if you recall, I said one of the easiest ways that we can do this is simply by choosing, let's say, x or y that we want to eliminate, and then use that constant that's in front and multiply that by the other equation, okay? Now, if that sounds kind of confusing, this is really what I'm saying. If we wanted to eliminate, let's say we want to get rid of the y's here. Notice we have a 9 here and a 4 here, or a -4 and a -9. If we multiplied a 9 to the first equation and a 4 to the second equation, then we'd have 9 times 4 and 4 times 9, okay? Now, the only thing about that is we have to also create opposite signs. Currently, we would have 9 times a -4 and 4 times a -9. Both of those would result in a negative number. So in order to create opposite signs, we just need to change one of these, such as maybe we can multiply by a -4. That way we have one positive and one negative. So let's try this out. Let's do a positive 9 multiplied to the first equation and a -4 multiplied to the second equation, okay? So let's try this out. If we multiply, there we go, a positive 9 to the first equation, and then we multiply a -4 to the second equation, we're going to try to create opposite coefficients so we can cancel out y. Well, 9 times a -8x is going to give me -72x. 9 times a -4 is going to give me a -36y. And then we have 9 times a -4 again to get a -36. And then we're dropping down, this is our new equation, dropping down to the second equation. So we have 4 times a -18, or excuse me, a -4 times a -18. Two negatives make a positive, so we're going to get 72x, okay? Then we have a -4 times a -9. Two negatives make a positive. 4 times 9 is 36y. And then we have a -4 times a -9. Again, that's also going to be a positive, but a positive 36. And this becomes our new equation. Now with elimination, now that we've created opposite coefficients, we have a -36 and a positive 36, we just want to add the two together. But actually, notice we've actually created opposite coefficients here as well. So those guys are going to cancel out, and our constants are going to cancel out because they're opposites as well. And that actually plays into what we're talking about in terms of a true statement. So let's just add this together and see what we get. Well, a -72x and a positive 72x, those guys are going to cancel out. We basically get 0 if you want to write 0. And then again, these guys are going to cancel out, and we're going to get 0, okay? It doesn't really matter. We could just say they cancel out, but I'm going to write 0 for now, okay, just so that you can see that we get a true statement. And then a -36 and a positive 36, again, they'll cancel out, or we could put 0, okay? Now, the reason I'm writing zeros here is that you can see the true statement. So 0 plus 0, okay, is going to give us 0. And then does 0 equal 0? Well, yeah, that's a true statement, right? 0 does equal 0. So since we have a true statement, what we said earlier up here is that that's going to result in infinitely many solutions, okay? So we have infinitely many solutions. Okay, so anytime we have a true statement, we have infinitely many solutions. Anytime we have a false statement, we have no solution. Okay, so that would be our answer.